This is Vijay and I hope you're doing well. In this video lecture we will discuss on multiple choice questions on basic thermodynamics which is generally asked in all types of mechanical competitive exam. Let us start with question number 1. Heat flows from a cold body to a hot body with the aid of an external source. This statement is given by option A, Kelvin statement, option B, Clausius statement, option D, Joule statement, option D, Gay-Lussac statement. We know that there are two statements of second law of thermodynamics. The first one is Kelvin-Planck statement and second one is Clausius statement. According to the Kelvin-Planck statement, it is impossible to construct an engine or device which produces 100% efficiency. And second statement is Clausius statement, and according to this statement, it is impossible to transfer the heat from lower body temperature to higher body temperature without giving any external work. If you want to clear your fundamental in thermodynamics, so I have already prepared one video on basic on thermodynamics as well as on second law of thermodynamics, and you can watch it in my playlist of thermodynamics. So the right answer is Clausius statement. Heat flows from a cold body to a hot body with the aid of an external source, and this statement is given by Clausius. Question number 2. Second law of thermodynamics defines option A, entropy, option B, heat, option C, internal energy, option D, work. So we know that second law of thermodynamics defines entropy, and entropy means it is the disorderness of the process. Question number 3. The state of a substance whose evaporation is from its liquid state is complete is known as option A, air, option B, vapor, option C, steam, option D, perfect gas. Okay, we know that in Rankine cycle basically there are four components: pump, boiler, turbine and condenser. So here you can see that 4B1 it is the process in boiler, heat addition at constant pressure. Then after 1 to 2 it will occur in turbine, isentropic expansion process in turbine. We know that turbine means it is a one type of expander, and theoretically we can say that the process will be take place at isentropic, but practically it is adiabatic process. So in TS diagram, turbine process it will be represented by 1 to 2 and 2 to 3 it will occur in condenser. During the process 2 to 3 temperature remain same and it will occur in condenser, and 3 to 4 process it will occur in pump, isentropic compression. So as we know that in this dome the left hand side portion will represent the liquid region, middle portion of the dome it will represent the liquid plus vapor, and right hand side of the dome it will represent the gas phase. So the question is the state of a substance whose evaporation is from its liquid state is complete. Okay, so this is the liquid state. Here the moisture content is totally removed at one point, and here the dryness fraction is 1, x equal to 1, and it is called perfect gas, and it is also called superheated steam, and it will behave as a perfect gas. So the right answer is option D, perfect gas. Question number 4. The state of a substance whose evaporation is from its liquid state is partial is known as option A, air, option B, vapor, option C, steam, option D, perfect gas. We have already discussed in our previous slide. Okay, if the total evaporation of the liquid state is not completed, it is called vapor, and if the total evaporation of the liquid state is completed, it is called superheated steam or gas. Question number 5. The behavior of superheated steam is similar to that of option A, air, option B, ordinary gas, option C, steam, option D, perfect gas. Okay, we have already discussed in our previous slide. Okay, if the total evaporation of the liquid state is completed at saturation point or 100 degrees Celsius, at that time whenever we supply the more heat, it is called degree of superheat. At that time the steam is converted into superheated steam, and it will behave as a perfect gas. Okay, and it will obey all thermodynamics laws like as ideal gas equation, Charles law, Boyle's law, Clausius law, etc. So the right answer is perfect gas. Question number 6. The variables which control the physical properties of a perfect gas are: option A, volume occupied by gas; option B, pressure exerted by the gas; option C, temperature of the gas; option D, all of these. So the right answer is option D, all of these. Question number 7. The behavior of a perfect gas undergoing any change in the variables which controls physical property is governed by: option A, Charles law; option B, Clausius law; option C, Boyle's law; option D, all of these. And according to the statement of Charles law, V proportional to T, and according to Clausius law, P proportional to T, and according to Boyle's law, P proportional to 1 upon V. Here the right answer is option D, all of these. Question number 8. Dash state that change of internal energy of a perfect gas is directly proportional to the change of temperature. Option A, Charles law; option B, Clausius law; option C, Boyle's law; option D, Joule's law. Right answer is option D. Question number 9. Equal volume of all gases at the same temperature and pressure contain equal number of molecules. This statement is given by: option A, Avogadro's law; option B, Poisson's law; option C, Joule's law; option D, none of these. So the right answer is option A. Question number 10. For a perfect gas, according to Boyle's law, option A, PV equal to constant if temperature is remain constant; option B, V by T equal to C if pressure remains constant; option C, P by T equal to constant if V is kept constant; option D, T by P equal to constant if V is kept constant. We know that according to Boyle's law, pressure and volume both are inversely proportional. Okay, whenever we increase the pressure, so at that time volume of the gases will be decreased whenever the temperature remain constant, and whenever we increase the volume, at that time pressure will be decreases. So the P proportional to 1 upon V, so PV equal to constant. So this statement is given by Boyle's law. So the right answer is option A, PV equal to constant. So whenever we remove the proportionality, so PV equal to constant, at that time temperature remain constant. So the right answer is option A, PV equal to constant if temperature remain constant. Thank you friends for watching this video.